In this video, we are going to learn how to solve logarithmic equations and exponential equations, but mainly logarithmic. But before we do that, let's do a little bit of review of these properties that we learned. So if I have log base 7 of 7, I know that I'm asking 7 to what power is 7? So 7 to the first power is 7. This is called an identity property because these basically cancel each other out. So what about when it's something like this? For log base 4 to the fourth, log base 4 of 4 squared. Oh, English. Okay. Now, this is a big mistake a lot of people make. They think this cancels out and it becomes 1 squared. That is not the case. So think about it like this. Remember, this 2 comes up front. So this is the same thing as kind of saying 2 times log base 4 of 4. And log base 4 of 4 is, we said, 1. So 2 times 1 is equal to 2. So whenever I have something like this, yes, these kind of still cancel each other out, but the answer is the exponent. So if I have log base 7 of 7 to the 8th, the answer is going to be 8. These cancel each other out, but still the 8 stays. Okay, log of 10. Now, what is the unmentioned or unidentified base here? Well, the unidentified base here is technically a 10. So log base 10 of 10 is, as we've been saying, 1. Okay, now what is the natural log the same thing as saying? Well, it's the same thing as saying log base what? E. Natural log is log base E. So this is saying of E cubed. So log base E of E. So natural log of E, these cancel each other out. And what do I get? I get 3 as an answer because of that exponent. And then here we have log base 2. This kind of looks like it says minus 4. This should be in parentheses. Log base 2 of negative 4. So the question we have to ask is 2 to what power equals negative 4? So 2 to the x equals negative 4. Well, what power can I raise 2 to in order to get negative 4? Does 2 work? No, because 2 squared is positive 4. 2 to the negative 2 is not negative 4. It's going to be 1 over 2 squared, which is 1 over 4. So what can I raise it to get negative 4? Well, nothing, right? There's no exponent that I can raise something to in order to get a negative number out. So it does not, DNE, does not exist. It is not, basically, you cannot have a negative inside of a logarithm. It is not in the domain. So no negatives. And then we have log base 3 of 0. So the next question is 3 to what power will give me 0? 3 to what power will give me 0? Well, 3 to the 0 is 1. 3 to the, I don't know, any other power is not going to give me 0. Nothing is going to give me 0. So I know that 3, anything with this also does not exist. So no negatives or 0 inside logs. So what we're going to see when we're solving is that sometimes you may or may not get a negative output or a negative number inside of a log. So then you would have to take that solution out. So how do we solve a logarithmic or exponential equation? So first we're going to want to isolate the log or the exponent or the exponential portion of it, right? So for this one, we're going to want to isolate this. For this, and it says here, you may need to condense the logs. So for like this one, we're going to have to bring them together using our properties, okay? Change to the other form. Originally, I had just logarithmic and then change to exponential form. But if it's exponential like these two, we're going to want to change it to exponential form. And then you solve, and then you're going to want to check your answer. So let's do some examples. So first, we want to isolate the log, right? Here, the log's already isolated. There's nothing around it. Now, if there was like a 2 up here or a -8 over here, then yes, we would have to isolate it. But here it's already isolated for us. So check. Next, change to the other form. So I'm going to change this from logarithmic form to exponential form. So how do I do that? Well, my base is 3, so it's going to be 3 to the 4th power equals x plus 1. So I'm going to rewrite that. 3 to the 4th power equals x plus 1. And so from there, I just solve. You're back to algebra 1 problem, right? 3 to the 4th power is, and you can go, I actually have it here. You can go on to desmos.com/scientific. It has a scientific calculator, regular, if you don't have one at home. So 3 to the 4th power is 81, right? So I'm going to do 81. 81 equals x plus 1, and then I subtract 1. And so I get x equals 80. And then I just want to check it. Now, this is an easy check. If I plug 80 into this, I get 81 inside, and we're good. So you really just want to make sure you don't get a 0 or a negative inside of a logarithm. All right, let's try another one. So for this one, we want to isolate the logs, but the issue is that there's not one log. You want one log per side, if possible. And the issue is if I wanted to add this here, let's say I wanted to be like, okay, I'll put the other log on this side. That one stops you from using any other property. So your best bet is to condense them. So what do we know from our properties that minus does? When we subtract, what are we going to do with the stuff on the inside? Well, we are going to divide. So I'm going to change this to log base 5 of, I'm going to keep that equals 1. So this divided by this. So I'm going to get 4x plus 5 divided by x. Because of that minus, I divide. And then now we have a isolated, I forgot the word, an isolated log. So then we go from there. I can change it to logarithmic form. And so I go from 5 to the 1st power equals this. So 5 to the 1st power equals 4x plus 5 over x. Now, the biggest mistake you can make here is cancel these x's out. You cannot do that. So what you're going to do is you are going to, well, 5 to the 1st is just 5. So I'm going to just rewrite this. I am going to multiply this x to the other side because I want to get rid of this denominator. And so I get 5x equals 4x plus 5. Now we're in equation land, and we can subtract that 4x. This is back to algebra 1. 5 minus 4 is x equals 5. Boom. And then we just want to check. If I plug it in here, I get 4 times 5, 20, plus 5, 25. And then 5, if I plug it in here, then we're good. It's just a 5, not a 0 or a negative. Again, really important to check that. Next one. So this is not logarithmic, this is exponential. So what we're going to do is we want to isolate this exponential portion of it. So what do we have to get rid of? We have to get rid of this 5. So I'm going to add the 5 over here. And so I'm going to get 2 to the 2x equals 64. Now I'm going to change it to logarithmic form. So I isolate it and then I change forms. So it's log, the base always stays the same, log base 2 of 64 equals 2x. Log base 2 of 64, you can technically do that, or you can use a calculator, but you could do that. 2 to what power equals 64? Well, if you want, you can do this. 2 to what power? So you can test some numbers out. So 2 to the 5th is 32. 2 to the 6th is 64. So I know log base 2 of 64 is the same thing as saying 6. So 6 equals 2x. And so if 6 equals 2x, I divide by 2. And so I get x equals 3. This one you do not have to technically check because there's no logarithms in the original problem, so there's no restriction on our domain. Okay, next is, we have to do the same exact thing. Now, is it isolated? Yes. So we don't have to worry about isolating it because it's already isolated. You cannot subtract 1 here because it's in the exponent. You cannot take anything out of the exponent unless you change forms first. So I'm going to change forms, right? Log base 5 of 18 equals this. So log base 5 of 18, I'm going to make the base a little bit clearer, of 18 equals x plus 1. So here's the issue. 5 to some power will never equal 18 unless it's a decimal. So we need to use the change of base formula, to pretty much get it to something we can solve. So what we learned from the change of base formula is that if I have log base b of x, it is the same thing as saying log of any base of x over log of b, or you can do the natural log of x over the natural log of b. Either way it works. So I'm going to do log, remember log by itself is 10, so log of 18 over log of 5 equals x plus 1. And so I'm going to go to my calculator, and I'm going to go to function, and I'm going to do log of 18 divided by log of, what was it, 5? Yeah, log of 5, and I get 1.7959, let's say. So this is equal to 1.7959 equals x plus 1, and then I just have to subtract 1, which is super easy. We just take that 1 out. So the answer is going to be 0.7959. Again, you don't have to check it because it's not logarithmic, it's exponential.